welcome back for part 4 of this 3-part series. I am splitting up this last video here, this last section, just due to not wanting to have too long of a video portions of it. So in the first part of this, what we did is we set ourselves up these kind of teleport zone tools that will be able to, place and kind of stretch around the world as we need to. And now what we need to do is we actually need to create the communication such that we can talk to them, request teleports, and that kind of thing. So let's go ahead and set that up. The first thing I'm going to do here is I'm going to close this post. I don't need to look at materials anymore. And we're pretty happy with our function library right now. And so what I was doing is we were creating a interface that we can talk to them. So here we're going to go and we're going to rename this to request teleport, because we don't know that what we're going to talk to is going to be anything useful, but we do need to send whatever it is our player location, so it has something that it can generate these barycentric coordinates off of. So here's our vector, and so right now it's just we're gonna tell it we want to teleport, this is where we exist, and then we will let the teleport zone decide if it wants to do anything with that information. And so what we will do here is in our event graph, actually we're going to go to class settings and we're going to add in our interface for teleport zone interface. Compile that, and I will drag off of that. This is the request teleport. We need the event request teleport. So this is assuming we get a player location. We are going to need now on our end to decide whether or not that player is in this first triangle or the other triangle, because the assumption is if we're overlapping, we should be somewhere inside of it. It should be valid. All right, so what we're going to do here is we're going to create ourselves a function here that basically we're going to give it a coordinate. We're going to basically just kind of wrap how we're going to talk to our barycentric coordinate function library. So I'm going to make myself a new function here, and this is going to be get barycentric coordinates, and we're going to do this the same way that we did the other one. So I added here an input. This is where we're going to plug in our player location. We can get access to all of our spline points here, and we need to know which triangle we're inside of. So we're going to basically spit out two different values here. We need to spit out, first off, we need to spit out our barycentric coordinates, and we need to spit out a kind of just an indicator if it's triangle 1 or triangle 2. This is somewhat arbitrary right now. We're just going to call this one, the bottom left, triangle 1. We're going to call this one triangle 2. So this is going to be is triangle 1. The idea being, if it is, we will apply on the other end our coordinates to this lower triangle. If it's not, we'll apply them to over here. That way we don't end up in some kind of a wonky location compared to what we're expecting. All right, so going back here then, so calculate, so type in barycentric, so get barycentric coordinates. Oh, that's us. All right, let's see, convert into barycentric coordinates. So here we have, we're going to get the player position, and we're going to need to do this twice, once for each different triangle. And so what I'm going to do here is get location at spline point, and we need the world location. Instead of being in local, we need the world location. So here's 1, 2, 3. Plug these guys in. There's point A, point B, and point C. And so this is where we have to make sure that we are properly indexing the right points. So we know that for our viewport, this is point 0, point 1, point 2. So this triangle will be here, and the next one we need to send it in the right order, points 1, point 2, and point 3. So 0, 1, 2. This gets us the barycentric coordinates for this one. And the idea being, we now just need a branch. So this is in first triangle. So the logic here is, if this gives us valid coordinates, we were inside of it. So fantastic. We should return those values and we should move on. So we're going to promote this value to a local variable so that we can return it properly. This is going to be UVW return values. And then we will run our return node. And we will also promote this to a local variable, is triangle 1. All right. We will set that to true. So now I'll just return these two different values here. Now, if it's not, if it turns out that these values are wrong, then we need to return the second one. So we need to go into the other triangle. And this is a situation where we know that we can go in either triangle, and we're going to have, since we're going to do this with overlaps, we should be pretty sure that we're going to be overlapping. So we may have to adjust the sensitivity of how this particular Boolean value is calculated. But, oops, Control V. Let's Control C, Control V, and Control C, Control V. So I have another copy here. So this is for the other triangles. Instead of going from 0, 1, 2, we need to go from 1, 2, 3. Plug that in again. Drag in our player location. And we can add in some logic here if we are concerned about this allowing teleportation to occur if we're not actually inside. So we'll add another branch here just in case. And the assumption here is, see, is in second triangle. The idea being, if we're not quite right, we just want to print that there is an error has occurred. So error has occurred in get barycentric coordinate on teleport zone, or in teleport zone. Kind of wordy, but it tells us exactly where this error is. And the assumption is, as long as we're inside of it, we also want to run this after having set these two values. So we'll copy that, drag it here, we'll set those two again, and this time we will give it the information of that one, and we will turn this off so that we know that we are not inside triangle 1. Compiled, and now it is going to let us communicate with it. So we can test this portion out now after I plug it into our event graph. This is get barycentric coordinates. Plug in the player position, and we'll just leave that there and plug in the logic now so that the player can actually trigger this. So instead of teleporting to all these crazy locations now, we're just going to, from our character, from our input and fire, we can disconnect this, and this is all old useless. So I'm just going to say was for testing. And we'll get rid of that in a minute once we verify stuff is working. What we're going to do is, after it's pressed, we're going to get overlapping actors. We're going to get any of them of the teleport zone type. And then for each of these, because we don't really care which one it is, actually we're going to do one with a break here. You know what? Let's just do the first one. Let's just get a copy of the first one. No need to go super complicated with this kind of example. And we're going to send it a message. We're going to tell it that we are going to request teleport. It's asking for our player location, so we will get actor location. Plug that in. Compile. And now if I play this, I shouldn't go anywhere right now because I'm not overlapping. But if I walk over here, let's see here. Make sure that's triggering. Event. String. Request teleport. I'm pretty sure I'm having an issue with just overlaps. So request teleport. And we're going to see if let's print out what this is going to give us as an answer. So it shouldn't give us anything unless we're overlapping. And yeah, we're having an issue with overlaps. So let's go in here and let's double check that we got all the overlaps set properly. And so we need to go to construction script, our procedural mesh. Should be overlapping everything. See if it's happier with that. Otherwise, what we can do here is we can add ourselves in a collision mesh. Oh, that's what it is. Yes. We need to actually provide collision for it. So let me turn that back to overlap all dynamic. And now it's actually telling us we're in zone 2. So yeah, so a little just quick button there, forgot to press. Here's teleport zone 1. I forgot to select create collision. So now it has collision. All right, so let's go back to our teleport. And let's see here. We don't need this anymore for debugging. We just want to send it that request teleport message. So that's finished. Let's go back to our teleport zone, our event graph, and we will double check. So we should be receiving it. Let's just add a quick print statement to verify we were receiving it. Receiving it. So now we just need to actually get the information out. So we just need to tell it to print this information. So we'll give ourselves 2 print strings and we will see what it's telling us for information. So there is our barycentric coordinates we're going to generate, and then we'll add a print statement for our triangle. So now we go over on one of these. So it is not triangle 1. Let's see here. Let's check the other one. It is triangle 1. All right, so part of this problem is potentially the fact that we are not giving it a location that is within the z height. So we have to send that. So So we need to actually add one more step in here for this overlapping to occur properly. What we need to do is actually cast downward and basically generate a point that we know is going to be on that plane. So let's do that. So on this event fire, what we're going to do is we're going to use our location. We're going to add in a bunch of z height to it. And so what we're going to do here is we're going to add, like, 500 or something. We will do a line trace by channel. And so the reason here is we need to guarantee, because we're doing now with this point is in 3D space. We're not guaranteed to even be on the surface of the triangle we're trying to hit. So we're going to start somewhere above us, and then we're going to go basically somewhere below us. And we'll make this visible. We'll debug this for a duration just so we can kind of see where it is we're hitting. And then we will split this hit structure out. And we will use this hit location as what we're going to send it as our player location. So this is kind of messy right now. Let me just clean this up a little bit there. So now if I hit play, you can see that I'm kind of casting down to the ground wherever we are. And if I do this, it should be overlapping. We're not getting a good overlap there. Let's see here, visibility. This is going to be an issue again in the teleport zone with our procedural mesh here. Overlap all dynamic, just overlap all. Okay, I'm back. I finally managed to track down the issue with the overlaps there. Took a little bit, random thing. Um, for line traces to work, it requires it actually has to be blocked. So since we're doing a single line trace, I needed to make sure that I had set the procedural mesh component. I had to change it from overlapping all to custom, and I need it to block visible and camera. Now we're able to walk over here and actually see it impacting the triangles, and we're also getting the message out of it is inside of it, or if it's not inside of that first quad, sorry, first triangle. And it now works for the one on the floor too. So it is properly now aiming downward and impacting those surfaces while still letting us kind of walk around through it for our purposes here. So anyway, back to the teleport zone logic. So we have here, we've requested information, we've double checked everything is working properly. Now we just need to make sure that we are getting our neighbor, basically, or the other teleport pad. I'm going to assume that we only have one, so I'm just going to get other actors. And so what I'm going to do is I'm going to just set a tag on the other one. This time we'll do it manually, and this is going to be tag A or tag B. So the idea is we want to go back and forth. So what we can do is actually not set a tag. Let's do it this way. Okay, I'm back. I finally sorted out the issue we were having with the line trace by channel. It was not on the line trace itself. It was in the teleport zone, specifically the collision stuff here. I needed to change my collision to custom, and I needed to make sure that I was blocking, not just overlapping, my visible. And so now that that is changed, I can walk over here and we can see that I am indeed hitting the mesh itself for our teleport zone, and I am currently not returning because I broke the connection there, but I am now properly hitting the those triangles. And so now the next step we need is to basically go back and forth and communicate between the two teleport zones. And to do that, what I'm going to do is make it a very simple connection. We're just going to do a get all actors of this type. So get all actors of class, and we're going to do teleport zone. And we know that we are going to, this is going to result in us producing two actors, either ourselves or the other teleport zone that we want to show up in. And so we're going to do a for each loop with a break. And the reasoning behind here is once we find, it's either going to be the first one we find or the second one we find, but once we find the version of the teleport out there that's not us, we're going to break this and use that information then. So basically we're going to check is self, so is equal, and we're going to get this, so this reference is going to be is it equal to, we're going to get a reference to ourself. And to see what's going to happen here, let's just print this for the two of them. If you haven't noticed yet, I'm a huge fan of print statements, just to kind of begin showing the logic rather than setting up the entire project all at once and then just hoping it works. I really like to make sure that you can kind of follow through with the logic as you go, and print statements are fantastic for that. Okay, so the first time it goes through, it says false, then true. So one of those two was us, the other one wasn't, and this one is going true, then false. So obviously it's always finding one of them first, then the other. And so the idea is, as long as this is not us, we can branch out from here. So as long as this is not us, we want to do two things. We first want to do our teleport, and then we want to make sure we break this so that we don't continue looping through here. just for you know, cleanliness sake. It's not terribly long. We won't do anything the second time, but you know, this would be proper to break it if we find the right one we're looking for. And so, assuming that we haven't found us, we want to teleport to it. So we want to communicate with it, and we need to give it a communication that it can get. So this is going to be a new function we're going to add here, and this is going to be teleport, or this is going to be teleport player. And we need to make sure that we give it an input. This is going to be our UVW coordinates. And it doesn't need to have any kind of output, but we do need it to have a Boolean of is triangle 1. Compile that, go back here, and we will then send the message teleport player to whatever that was. Target is teleport player. I don't know if I sent that the right way. Teleport player. That should be good. Okay. We will send it then our barycentric coordinates and our triangle information. And now we just have to set up the logic for what it's supposed to do on the receiving end. So I will add in here our teleport player. So there's our event teleport player. So this is assuming that we have received those coordinates and that triangle. We need to now convert it out of, so this is going to be convert out of barycentric. And so here is where our logic, so if it is, we need to have a branch here. So if this is our first triangle, then we need to send it the first 3 points. If it's not, we need to send the other ones. So I'm going to add in here, I'm going to promote this to a variable here. And because we have all this, I'm going to put this in its own category. And this is going to be target point A. We're going to give it a category of teleport points, teleport triangle points. And promote this. Teleport point B. Add to there. And I will add in one more teleport point C. And that one came in because I did it differently as an array. All right, there we go. So we've got that. We know we want to send it these. So our only logic then required from here is going to be to set up what these particular points are. So what we're going to do here is we will grab our spline, and if it is, so we're going to do this way. We're going to do a get location at spline point. And we're going to do this the simple way just because I don't want to worry about necessarily too much more time here on this kind of this tutorial thing, because I know we've been doing this video for a while, and so we're just going to make sure we get this guy done. So there's 1 and 2. So there's 1, 0, 1, 2. There's our first triangle, and this is the assumption of we are. So we will grab our set values here, point A, point B, point C. So if we are in the first one, and then if we're not, what I'm going to do here is I'm just going to copy this. So we just need to get a copy of that. And if we're not, we will run this set and we will do points 1, point 2, and point 3. Now, I do need to make sure I'm changing all of these from local to world. These do need to be world coordinate spaces. And then afterwards, we'll grab ourselves a reroute node because we need to combine, because once we're done, we just need to figure out which one we're going for those. And now we just need to set the player location. So this is going to be, actually for this, we will grab ourselves, we need a reference to basically who requested this. So let's go back here to the interface. Request teleport. We're going to add in one more here. It's going to be an actor reference. This is the requesting player. And I do need to add it to this teleport player. Compile that. So I will just route this through the requesting player. And now I can drag out from here, set actor location. And there's our new position. Let's compile that and go back here. Make sure for this, we're grabbing ourselves a reference to ourself under our first person character blueprint. And we can test this out now. So if I go over here, I have wound up in this little corner. Now I should be able to go over to this corner, and I wind back up over here. And so I am correctly teleporting back and forth between my two zones. So there we go. There is our working system. So now we can basically get as creative as we want, putting them anywhere. So I could technically put this, let's just drag this entire thing up here. And I'm going to put this guy, let's just drop it there. I can play around with, I'll put that over here. There we go. Hit play. And now I can teleport myself up there. I can be in a specific corner if I need to be. So hopefully this hasn't been too confusing. Hopefully you guys have been able to follow through with what I've got here. Barycentric coordinates are extremely powerful and useful. This is just one way of using them. And so hopefully this will inspire some people to make some even better and cooler things than just what I've got here. I will probably at some point try to provide a link for my library functions that I have that we've created from here, just for reference purposes if you're interested. So I'll make sure I can get those out and those available. Have a great day. Thanks for watching.